Hello out there, we're on the air. It's algebra tonight. Um, okay, so we're gonna do a video lesson here, folks. Today's agenda, we're gonna want to talk about the expectations for today, some questions. Guess you won't have any, and then look at the lesson 3.5. Um, you are expected to watch this video, and this is something we've talked about before, that even if I'm not in the classroom, the class still moves on. If not, the lesson will be available online in the PDF form if you can't access this video. So the expectation is that you go through this lesson and do any of the questions, and if you have problems, to ask questions tomorrow. Okay, so we're going to look at factoring trinomials. So remember, a trinomial is a polynomial that has three terms. So we've got x squared plus bx plus c. So I'm going to skip over this example and kind of go straight to the investigation. So we first started looking at the grid method, the table method, using the algebra tiles. So one of the nice things, there are three tiles here. One of the nice things about the algebra tiles is that it will give you the factors immediately with almost zero work. So all we have to do is kind of record what is on the outside. So remember, these were x tiles, these long skinny ones, and these were ones tiles. So here we've got an x plus 1, and here we have an x plus 3. So then when we factor, we're looking at, we want to find the dimensions of the sides. So completing this statement here would be that it's x plus 1 times x plus 3. So we're going to do lots of examples of these, excuse me, and we'll take it from there, and it'll get easier as we go through them. Okay. So if we look at this one, there should be a line there. What are the dimensions I have on the outside if I have the inside of my area to be x squared plus 3x plus 2? Well, I can see that I have an x tile and an x tile. Here there's a plus 1, and here there are plus 2. So this would be x plus 1 times x plus 2. And I think you can kind of see where this is going. Same idea here. That should look like that. So I have x here, I have 3 here, plus 3. Here I have an x, and here I have a plus 2. This would be x plus 3 times x plus 2. We're going to leave it at that, and we're going to come to looking at factoring trinomials. There is another way, and we're going to look at that one in a second. Another way to factor a trinomial in the form of x squared plus bx plus c is to study a general expansion. So what they mean is we're going to take the general case of x plus m times x plus n. We all know how to do this now. We can use either FOIL method, the table method, the chart method, or the algebra method. So by expanding it, we get x squared plus nx plus mx plus mn. The middle terms have x in common, so when we factor that out, we're left with m plus n in brackets. So then how do these terms match with those terms? Well, the b term has to be m plus n, and the c term has to be m times n. Notice that it was 1x squared and 1x squared. So in the exact same comparison, they said that B has to equal M plus N and C has to equal M plus N times N. So what we're going to do is we're going to use this information to try and figure out what two numbers will give us our factors of our trinomial by looking at what two values multiply to a certain value and add to another value. That sounds a little confusing, but we'll try here and hopefully it'll make some sense here. Excuse me. So we need two numbers to multiply to 12, but add to give us. Okay, so let's just go through all the factors to multiply to give us 12. Well, we can multiply to get 12, so we can go 1 and 12, or minus 1 and minus 12. We can also go 2 and 6, or minus 2 minus 6. We could also go 3 times 4, or minus 3 times minus 4. The next one up here would be 6, and then it would be 2 again, so it's going to loop on itself. So these are all the factors that multiply to give us 12. So multiply, oops, also 1 times 12, this would all give us positive 12. So now we need to find which ones add to give us minus 8. So all we're going to do is add these. We get a 13 minus 13 plus 8 minus 8. So now that we've got a value of minus 8, we found our solution. So therefore our factor will be x minus 2, x minus 2 times x minus 6. So just to highlight what we've done here. We have to look at two numbers that multiply to give us plus 12. So those are the values that we set up in our table. Then we have to find out which ones add to give us minus 8. So once we've done that, we get our value. So then we get the values of minus 2 and minus 6. We don't change the signs, we don't do anything, we just write them in brackets. X minus 2 and x minus 6 as our factors. Just going through the exact same thing where they use the finding all the products and then find what the sums are. And so it's the exact same way we had done it. Now, one thing I wanted to mention, if we started off with a trinomial, and we put it in this condensed form, the process of going from the trinomial to the two binomials is known as factoring. When we take the multiplication of the binomials and we put it in the expanded form, it's known as expanding. So we take a trinomial, we factor it into two binomials, the multiplication of two binomials. If we have the multiplication of two binomials, we can only expand it into a trinomial. So I'm just going to demonstrate this using the algae tiles. Actually, I'm going to use both methods. When we're using the algebra tiles, what's kind of nice is that, like I said, it'll give us our answer. So right now I'm going to use green as positive and the purple as negative. So right now everything is positive. So we have one positive x squared tile. We have four. So the idea with this, when you're doing it in the algebra tile method, you want to start with the x squared tile and then go to the numbers, the single number on the end. Leave an 9x in the middle. So now we have to figure out how can we fill in 14 of these little blocks such that it forms a rectangle. So we just do like, excuse me, a row of 13 and then one below. So you have to form a rectangle. Well, we could either do one row of 14 or we could do a 2 by 7. 1, 2, 3, 4, 5. Oh, look at that, perfect. So now that leaves, notice these tiles here. So I've kind of defined where my area could potentially be. It would end here on the vertical one and here on the horizontal. So now we just got to figure out what to do with these highlighted ones, or the non-highlighted ones, sorry. Well, if to be colored in, since it's got to be positive, I have 2 here and I have 7 here. Well, what's 2 plus 7? Well, it's 9. Green would be a bad choice. So I have 7 here and 2 there. And look, I'm trying to get 9 X tiles. So remember, the skinny ones are X tiles. So by putting in the information, I've got it all in correctly now, it tells me what my solution is. Well, I have an X plus 2 multiplied by X plus 7. So then this answer would be X plus 2 times X plus 7. So let's look at this question using the approach we used earlier. So I'm going to start again. X squared plus 9x plus 14. I need to find two things that multiply to 14 and add to 9. So going through all the factors of 14, we've got 1 and 14, minus 1 minus 14, 2, 7, minus 2, minus 7. And again, we won't have any other ones from there. So now looking at adding. Well, 1 plus 14, 15, negative 15, positive 9 minus 9. We were trying to get 9x, so therefore a positive 9. So we're looking at, there's our answer, and therefore x plus 2 multiplied by x plus 7 are our factors. If at any point you want to pause the video, you can always go back and read something and listen to it again if you need more explanation or clarification on a question. So coming here again, and I'm going to start by doing the algebra tile method. We have an r squared, a positive r squared. So when we have negatives, it gets a little harder using the algebra tile method. And like I said, this algebra tile method isn't for everyone. It does help. Okay, so then we need to get minus 8. So again, it's just changing the colors. I've got to try and figure out 8 such that it forms a square or a rectangle. Well, the only way to do that is a 2 by 4, and it's negative. Now notice our middle term is negative 2. Now if I look here, I kind of set where my area would go to by looking at having my original rectangle. Now in this area down here, I've got 4 X tiles. Up in this area, I've got 2 X tiles. Now is there any way that by changing the colors either from a negative or positives, we can get minus 2 with 4 and, or minus 2x with 4x and 2x? Well, in order to get a negative 2, we'd have to have this 4x would have to be negative and our 2 would have to be positive. So these guys would have to be negative, whereas these guys would have to be positive. So now we have to figure out what colors are going to be on the outside. Well, since this is a negative, we know that these two have to be positive because an x times an x will have to be x squared. So we're always going to have a positive for our value here. So then, if we have a positive multiplied by what will give me a positive, right? Because where they intersect, that's where the colors will meet when it comes to a positive or negative. So this one will be positive, and this one will have to be negative. And if we look again at the intersection of the lines, And again, I'm just doing it in general because I would have to do it for every single term. We've got positive multiplied by a positive to give us a positive value. Here we've got negative values multiplied by a positive to give us negative, and a negative multiplied by a positive to give us negative values. So now we have our answer on the outside to give us x minus 4 and x plus 2. So we would have x minus 4 times x plus 2. Looking at it in that approach, so again, need to multiply here and add here. So we're going to think of all the factors that multiply to give us minus 8. Well, we've got minus 1 and positive 8, or 1 and minus 8. We could also do 2 and minus 4, or minus 2 and positive 4. And again, those are all our factors because you can't have 3. If we go to 4 again, you're going to have 4 times 2. So I always start off with 1 and multiply by what to give us my second value. Starting off with 2, 3, and you continue down the line until you have the repeating factor. Okay, so this is the multiply, and this is the add. So adding these together, we're going to get 7 minus 2, and positive 2. We are after getting minus 2, so there's our answer. So again, I'm going to start off with using the algae tile method. We've got plus r squared and minus 3, and again, minus 3 can only be done by one rectangle. Now, we have to do the analysis of we've got 3 tiles here and 1 tile here. Well, if I've got 3 tiles here and 1 tile here, how can I end up with plus 2 with 3 and 1? Well, it would have to be plus 3 and negative 1. So therefore, we have to then color our table in accordingly. So again, our tables are ending here based upon where we had drawn our rectangle on the bottom. Now we just got to figure out colors on the sides. Well, these ones we know are always going to be positive. And you could probably guess. So then, again, a positive times what would make a negative? Well, that's only going to reduce. The only option is if this was negative. And here you've got a positive times something to give us positive. So it will have to be positive. That results in x plus 3 and x minus 1. Okay, so again, looking at it in the other approach, we need to find two things that multiply to minus 3 that add to 2. And there aren't as many factors in this one, so it's a little nicer. So we've got 1 and minus 3, or minus 1 and plus 3. There's no other factors that multiply to give us positive 3, or 3, sorry. So we're just going to add these together. We get minus 2 or plus 2, and we're looking at trying to get plus 2. So then there are our factors. Okay, I want you to try this one. You can pause the video, go ahead and try the question, and come back to the video. I'm going to go ahead and do the solution, but be sure to pause it and go through the question yourself. So we've got 1 positive, we've 6 negative. And now I've got 3 tiles here and 2 tiles here. So with the 3 and the 2, I need to get a negative 1. So therefore, the 3 would have to be negative, and the 2 would have to be positive. So I've defined my borders when I first drew in my ones tiles. Again, it's just figuring out what they are on the side. Well, I know that these x's are positive. So starting with the top one, something times a positive will have to equal positive. Well, that's going to be a positive. Here we've got positive times something will have to give us a negative, and that's going to be negative. We can always check the solution by looking at a negative times a positive to produce us with a negative. So we've got x minus 3 and x plus 2. So looking at the other approach, so we want to multiply and add. Multiply to negative 6, add to negative 1. So we've got 1 minus 6 minus 1, 6. 2 minus 3 or minus 2 plus 3. Again, no other factors. So now adding these, I get minus 5 plus 5 minus 1 and plus 1. We are trying to get minus 1. So there is our answer. So x plus 2 times x minus 3. Okay, I will leave this. You can try this on your own again. Pause the question, pause the video, try the question, and then come back to it when you have a solution. Just to speed things up a little bit, I'm just going to go forward and write the solution, and you can check your answers later. X plus 1 and x plus 8. All right, now we're going to look at where our value in front of the x squared isn't 1. Okay, so this is going to come by removing a common factor. So you're going to really recognize that something, this value, usually whatever's in front of the a, or whatever in front of the x squared, is common to everything. So we're going to remove it first. So we're going to factor 3 out. So what am I left with? Well, I'm going to be left with x squared plus x minus 6. So if I were to expand this back in, I would get 3x squared plus 3x minus 18, which matches my original question. So now I know I've factored it correctly. So once you have that, now it just becomes a matter of finding the factors of this using the same method before. So I'm just going to use that new table method. So the values that multiply to give us this, but add to give us this, just because I'm just saving a little space and time. So we've got minus 1, positive 6, plus 1, minus 6, 2, minus 3, and minus 2, plus 3. So these values add to positive 5, minus 1, and positive 1. We are trying to get a plus 1, so we're looking at this bottom one. So then our final solution would be 3 multiplied by, and I don't have to have the square brackets, I could have just round brackets, but I'm just using the square brackets just to kind of show the difference between the multiplications. So then we don't actually need to have these square brackets, so we can just write this simply as 3 times x minus 2 times x plus 3. So again, this second part is just working on the premise of what we had done in the beginning. So this is a little different question, but similar in nature. So it becomes even easier. um, because we have our v squared, but we have 0 tiles on the last one. So here we have what's common to both of these. Well, v is. So we're going to have v and v plus 8. And you're done. So the algebra tile method doesn't quite work out the same in this case because you can't necessarily draw 0 tiles, but you can. Um, we have an x, so we have x squared as our answer, and we have 8 tiles here. We have 0 ones tiles. I don't actually have, I only have 7 here, so I have to draw one more. So we have an x by an x plus 8. So it gets a little trickier when there's no numbers, but not impossible. Okay, again, recognizing that since the first value doesn't have a 1 in front of it, maybe you have to factor it out. So I'm going to try factoring 5. And what am I left with? Well, I'm left with b squared plus 3b plus 2. So now this is the thing that we're going to factor. And again, I'll do the tile method here quickly. I've got a b squared and a plus 2. So noticing we've got our area defined by the area, by the dimensions here. Up in this area, I have 1 tile. Over here, I've got 2 x tiles, and I'm trying to get plus 3. So that means that they both have to be positive. Since everything is positive, everything up top will be positive. So we're going to have a positive x plus 1 and x plus 2. So we're going to have a 5 times, well, b in this case, b plus 2 and b plus 1. If you were using the method of finding the two numbers that multiply one, but to this one, let's set it up quickly. So multiply, we've got 1 and 2 and minus 1, minus 2. Not too many options there. And again, adding, we've got plus 3 or minus 3. So we wanted our plus 3 value. So it's going to be the first one. So again, it would be 5 times b plus 1 times b plus 2. So factoring the 4 out, so kind of a big one here, but you can use a calculator if you need to. So I'm going to get a 1, 32, so it should be 18 minus 18. Now you can still go forward and use this method. I'm going to forego it right now, so I'm just not going to do it just to kind of save some time on this recording process. So we're looking at numbers that multiply to give you this and add to give you this. So every one of these questions, folks, you should be pausing it, going through the question yourself, and then coming back and watching the video to try and get the solution. So 18, there's a few more factors. So negative 1, 18, 1, negative 18, 2, negative 9, negative 2, positive 9, negative 3, positive 6, positive 3, negative 6. So now we're going to do the addition of all those guys. We're going to get 17 minus 17 minus 7 plus 7 plus 3 minus 3. We are trying to get minus 3, so it's going to be our last term. So our final answer would be 4 multiplied by x plus 3, x minus 6. Oh, and sorry. So now we're going to look at the last method for the day. It's trinomials with two variables. So what does that mean? Well, notice we've got x's. We also have y's. So I did this on purpose to show that there's a square here, squared here, and then single terms in the middle. When we had our regular x's, we were just with one variable, we had our x's on the front, and that produced our x squared. We had numbers here, and that produced a number with a single x term. And then we just had some final number because we had the two numbers multiplied. In order to get a y squared on the end, you're going to have to have y's on the ends of the same way that the x's are here. So that would produce a y squared when these two are multiplied, and the final one would also produce y terms in the middle. So the easiest thing to do is to forget about the y's, pretend it's just x squared minus 2x minus 15, just to figure out the numbers, then put the y's in on the ends of the factors. So to multiply and so we've got minus 1, 15, 1, and 15. Oh, 1 minus 15. 3 minus 5, and minus 3, 5. And that's all she wrote. So adding this together, we're going to get 14 minus 14 minus 2 plus 2. We're trying to get minus 2. So those are our answers. So writing out our factors, so therefore we would have x plus 3. I left a space intentionally. X minus 5. And on the ends, we tag on y's. So it would be 3y and 5y. So this one, let's look at the expansion of this guy. So this is kind of using the FOIL method. So we're going to get x squared minus 5y x, or 5xy, it's the same thing, plus 3yx and minus 15y squared. So collecting like terms, we're going to get x squared. Yx is the same thing as xy. It doesn't matter the order because they're multiplied. We're going to get minus 2xy, so I just switched it there so it matches my original, and minus 15y squared. So is this, so x squared minus 2xy minus 15y squared, is that equivalent to our original? And it is, so therefore this is the correct factoring. So same thing, what they had done, they kind of pretended y wasn't there and then just tagged it on the last two. You can use the same algebra tile method. You can use the one on the right. I'm just going to forego it. You can try it out if you want, just to try and make this video a little faster. So we have, again, pretend the ends aren't there. So we're looking at multiplying for this one and adding to get this one. And again, folks, you should be pausing the video, doing the question, coming back to answer it, or to check the answer. And now we need to add these together. We've got 11 minus 4 plus 4 minus 1 plus 1. We are trying to get minus 4, so minus 4 is the winner. So our final solution would be, what was it, m's and n's? M plus 2n, m minus 6n. Okay, so this is putting kind of all the eggs in one basket. Notice we have our leading coefficient isn't just a 1, so we're going to have to factor out first. U squared minus 15uv plus 112 divided by 2 is going to be 56. Yay, there's the answer. Um, we'll get to that point after. Okay, so again, we're looking at two numbers that multiply to 56, but add to minus 15. And you may think that's not possible, but it is, and we're going to go through all the factors. So there are a lot more to consider in this case. I'm not sure this table actually isn't big enough to handle 56 tiles, so we have to use this method. If you want to just keep extending the same pattern, and then you can have it large enough to hold 56 tiles. So we've got 1 and 56, minus 1, minus 56, 2 and 28, minus 2, minus 28, 3 does not work, 4 will work, so we've got 4 and 14, or a minus 4, minus 14, 5 doesn't work, 6 doesn't work, and what about 7? 7 works, and minus 7, minus 8, and then it's going to repeat onto itself. So now we're looking at adding these together. We've got 7 minus 57, 30 minus 30, so 18, sorry, 18 minus 18, 15, and minus 15. We were trying to get minus 15, and it was the last one. So putting all these together, we have our two factors out in front, and then our two factors of x minus 7. Oh, but they're not x's. The u's and v's are not. It's u and v. So we have u minus 7v and u minus 8v. And again, if I wanted to check my answer, I can expand it, or I could just move this down and we can see that is the correct answer. So some trinomials, such as x squared plus 3x plus 5, cannot be factored over integers. That means we can't get integer values. So if we look at things that multiply to 5, we only have 1 or minus 1 minus 5. If we add together, we're going to get 6 or minus 6, which is not 3. So therefore, it's not possible. So a lot of the times, if you can't come up with an answer, you're just going to write not possible. So some of the key concepts to factor a trinomial in the form of x squared plus bx plus c. You're going to first write x as the first term in each binomial factor, then write the second terms as they appear as b and c. So the sum has to be b and the product has to be c. So what that means is the sum has to be b, so this middle term has to add to this one, and the product has to be c, so it has to multiply to give you that one. The big one, when factoring a trinomial, so when you're factoring these kind of things, first remove any common factors, especially if you have any value in front of that first term, then you're going to need to remove the common factor. So you should be a hint that you need to divide that out. So exit card / homework, have the night off. I'll worry about that on Wednesday. We're going to have a little bit of a worksheet kind of day to start things off, see if you actually retain the information. So you will have to show me your skills on Wednesday. Well, I hope you enjoyed the video, and I hope the lesson goes well, and I will see you on Wednesday.